Hello dear students, welcome to Pen and Paper Chemistry on YouTube. In this video we shall be covering the topic of electrophile and nucleophile, more focused at the students of grade 11 and 12, right, or A levels according to some curriculum. In order to explain what are electrophiles and nucleophiles, just let us touch base on what do we mean by an attacking reagent. So when an organic reaction takes place, here I have taken the replacement of the halogen atom of the alkyl halide by OH group. So if you notice over here, RBr changes to ROH plus Br, bromide is released. Replacement, bromide is replaced by the hydroxyl group. So basically the hydroxyl group is the attacking reagent. My organic compound is the substrate. ROH, the alcohol formed as a result of this reaction, is the product, and bromide is the side product. What are the various categories of this attacking reagent? This attacking reagent in turn can be electrophilic in nature, this can be nucleophilic in nature, and this can also be a free radical. So we are going to distinguish between these terms. Free radical I shall take up separately. Today we shall be talking about electrophilic and nucleophilic. Before we go ahead with that, please remember the meaning of the word phile. Where you add phile means love, like, right? So when I say that a particular group is electrophilic, so that means just break it down. So we have over here electrophile, electron loving. That means this is a group which has an affinity for electrons. In other words, this particular group can either be positively charged or it can also be neutral but having space for electrons. So what we've got is electrophiles can be species which are either positively charged, for example H positive, Cl positive, Br positive, NO2 positive, NO positive, alkyl group with a positive charge. All these are examples of electrophiles with a positive charge. They can also be neutral with vacant orbitals in them. So for example, I take the case of BF3, boron trifluoride. Boron is 5, atomic number 5. 1s2, 2s2, 2p1. So I have here 2s gets excited and I have here 2s1 and 2p2 as the configuration. And according to Hund's rule, each one of them will first occupy the orbitals singly. By the way, I have already discussed the structure of boron trifluoride in my videos on hybridization, sp2 hybridization. So if you notice over here, my BF3, okay, I will say that this undergoes bonding with fluorine, fluorine, fluorine. If you notice over here, this orbital is vacant, into which it can accommodate a set of electrons. That means it has the capacity to take up electrons. Hence the word electrophile, electron loving, right? In other words, they are capable of accepting electrons. In other words, they are electron acceptors. And what are electron acceptors? A for acceptor, A for acid. They are Lewis acids. Please understand that we have to use the word Lewis over here depending on the concept of electron donation or electron accepting behavior. So A for acid, A for acceptor. Electron acceptors are Lewis acids. If they have the capacity to take up electrons, where do you think they will attack? Yes, at points which are rich in electrons. That means points which have high electron density or negative centers. I will give you time to write all of these notes. First, understand. Now what about nucleophiles? Now what is the charge on the nucleus? Yes, nucleus is positive, right? Loving. So that means a species which has an affinity for the positive charge. So what nature or what behavior will it have on its own? Yes, either it will be negatively charged, as we can see in the case of Cl negative, Br negative, OH negative, NH2 negative, Cn negative, Or negative. Don't worry, if you've not started with organic chemistry, you will encounter these ions during your study. For now, just understand step by step. Organic chemistry is not that tough, provided you learn the basics first. Coming back to nucleophiles, they can also be neutral but having an excess of electrons. I'm taking the example of ammonia here. You see over here we've given one lone pair of electrons. What is this lone pair? This lone pair is the pair of electrons which is taking part in hybridization. Remember, we did the structure of ammonia and water under the heading hybridization. So ammonia and water both have, oh yes, we've also covered it under VSEPR theory. Now ammonia, in the case of ammonia, nitrogen undergoes sp3 hybridization. But only 3 bonds are being formed with the hydrogen. So 1, 2 and 3. But notice over here, this set of electrons, which we call as the lone pair of electrons, is there, part of the hybridization but not participating in bond formation. That is why it is called as the lone pair of electrons. This lone pair, that means it is capable of sharing, right, if need be. Same is the case with water. Oxygen has 2 lone pair of electrons. If you are unclear about these concepts, there are videos on VSEPR theory, structure of ammonia, structure of water on the channel. You can go through them. So what we've got, nucleophiles may themselves be negatively charged or neutral with lone pair of electrons on them. Right. Now, if they have an excess of electrons, they'd like to share it, right? They are very nice. So that means they are electron donors. And what is a donor? Donor and base, right? An electron donor becomes a Lewis base. I'm not going to say it only as a base. Again, because we are talking about electron donation over here. Hence, they are Lewis bases. Now, since they themselves are negatively charged, where will they attack the molecule, the substrate molecule? Yes, of course, at the point where electron density is low. Remember, opposites attract in nature. Now, would you like to note these points down? I will share the complete screen with you just to give you an idea how you can compile these notes for a quick reference when you do not have your mobiles, your laptops or your screens with you. You can also share these notes with your classmates and friends who may not be lucky enough to have screens with them. So please go ahead, share this knowledge, copy down these notes, and it is always better to write it in your own hand. If you write it in your own hand, you will remember it also better. That's the hand-head-eye coordination. I've given them different colors also so that it's easier for you to recall and remember. I'm going to post videos on this topic so you can actually make a separate notebook for organic chemistry, which will help you to access these notes very easily. I shall also post these notes onto these are already actually there on my Google site, Pen and Paper Chemistry, the link to which I will share in the description box. But rather than taking printout, please use pen and paper to understand, to write down and remember the 3 R's of chemistry. See you in the next video.